Go. Hello, my name is Anne Jessica Tan, and welcome to my CS-499 Milestone 1 code review. This video represents the first major step in my Capstone project where I'll be reviewing existing code from my CS-340 course and planning enhancements for my professional e-portfolio. Before we dive into the code, let me give you some context about what you'll see today. I'll be reviewing a Python CRUD module I built for interacting with a MongoDB database containing animal shelter data. This was originally created for my CS340 client server development course. The plan is to take this simple database module and transform it into a complete web application and animal shelter management system. This project will demonstrate enhancements across all three required categories, one being software design and engineering, two, algorithms and data structures, and three, databases. Now let me open the actual code we'll be reviewing today. So this one here is the CRUD Python file that I will be using in its original state with line numbers visible, and this one is the test script that I will be using as well. For this code review, I'll follow a standard approach for each of the three categories. First, I'll show you what the existing code does. Then I'll analyze it against our code review checklist, pointing out strengths and weaknesses. Finally, I'll explain my specific enhancement plans and how they align with the course outcomes. So let's start with category 1, software design and engineering. Let me show you the complete existing functionality. This is a Python class called Animal Shelter that provides basic create and read operations for MongoDB database. As you can see here, there's the create and there's the read. Let me start with line 1. So we have a comment describing this as example Python code. Line 3 and 4 here, line 3 and 4, we have our imports, Mongo client from PyMongo, object ID from BSON. These are essential libraries for MongoDB interaction in Python. Line 6 is our class definition. Notice it inherits from object here, from object, which is the basic class in Python. Line 7 here has a doc string stating it provides CRUD operations for animal collection in MongoDB, though as we'll see, it currently only has here create and read, not the whole CRUD. Now let's look at the constructor. Lines 9 to 29 here. Lines 9 to 29, the init method is where the database connection is established. I want to point out several important things here as I scroll through. So starting with lines 10 to 16 here are comments explaining what this method does. And look at 18 and 19. This is critical because these credentials are hard-coded directly in the source code, which is a security concern we'll need to address. For lines 20 to 23, continue with other connection parameters, which are host, port, database name and column name, collection name. All, all of these are hard-coded as well. Line 27, this creates the actual MongoDB client connection using string formatting to insert our credentials and connection details. Lines 28 and 29, set up references to the database collection. This setup is functional but has several design issues we'll discuss in our analysis. Next, let's look at lines 33 to 40. Here, this implements the C, which is the create in CRUD, creating a new document in the database. And then here, look at line 35, has an input validation. This checks that the data parameter is not none and is dictionary. This is a good defensive programming. Line 36 performs the actual database insertion. This calls MongoDB's insert one method. And then we have line 37 returns the inserted ID. The unique the unique identifier MongoDB generates for the new document. And lines 38 to 39 handle the error case if the data is none or not a dictionary. It raises an exception with a descriptive message. And then finally, let's look at lines 42 to 52. This implements the R in CRUD, reading documents from database. So here, line 43 has similar input validation. This ensures the query parameter is a dictionary. Lines 44 to 49 contains a try except block. This is good practice for error handling. Line 45 performs database query. This returns a MongoDB cursor. Line 46 here converts the cursor to a list and returns it. This is important because MongoDB cursors are lazy evaluated. Converting it to a list forces execution of the query. Lines 50 to 51 handle invalid input. If the query is not a dictionary, it raises exception. So to summarize the existing functionality, we have a Python class that establishes a connection to MongoDB with hard-coded credentials, as you see here. It can insert single documents using create method and query for the documents using read method. What's notably missing are the update and delete operations, making this an incomplete CRUD implementation despite the class name and docstring suggesting it should be full CRUD functionality. Now let me analyze this code against our review checklist. So here's the review checklist that we have. So first, here we have the code completely and correctly implement the design. So partially the design implied by the class name animal shelter and it stocks during CRUD operations, such as a complete CRUD implementation. So, however, as we saw earlier, we only had create and read methods, but no update and delete methods. So the code correctly implements what it does have, but doesn't fulfill the complete design specification. Two, does the code conform to a pertinent coding standards? So here it's mixed compliance. So here line lengths are generally good. So it was under 479 characters. Variable name is clear and descriptive, but there are no type hints which are recommended in modern Python. Docstrings exist but could be more comprehensive. The code generally follows Python conventions but could be more polished. Third, is the code well structured, consistent in style, and consistently formatted? Mostly yes, with some inconsistencies. So the overall structure is logical, imports class definitions, constructor, then methods. The style methods methods is consistent. Also, some comments have inconsistent formatting. Fourth, are there any uncalled for or unneeded procedure or any unreachable code? No. All code appears to be reachable and necessary for functionality. There's no dead code or unused procedure. 5. Are there any leftover stubs or test routines in the code? There's one commented out stub, so it was in the line 31 here. I'll show you here. Line 31 here. Here you go, line 31. So this is a comment suggesting a method that was planned but never implemented. So it is not active code, but it does show an incomplete thought in the in the code base. So next is for the defensive programming part. So our imported data and input arguments tested for validity and completeness. Basic validation exists, but could be improved. Both create and read methods validate that their parameters are dictionaries. However, they don't validate the content of those dictionaries. They don't check for required fields in the data. They don't validate data types within the dictionaries. There's no protection against malicious input. So while there's some validation, it's not comprehensive defensive programming. So next, so major security issue, hard-coded credentials. As you can remember earlier about the lines 18 and 19, the username and the password are hard-coded in the core in the source code. This is a serious security vulnerability because first, credentials are exposed in version control. Second, cannot change credentials without modifying code. Third, different environments need different credentials. Fourth, violates the principle of separation of configuration from code. Next is error handling analysis. So for here, the read method has a try except block lines which are lines 44 to 49, which is good. However, so the create method has no try except block The exception handling in read catches all exceptions with exception as but it should be more specific. Error messages are printed out but not logged properly. Empty list return on error in read might hide problems from calling code. Next, documentation analysis. There are some comments explaining what the code does, but no docstring for methods, no parameter documentation, no return value documentation. Comments explain what, but not always why. So, um, my analysis reveals several key areas for improvement. First one being incomplete implementation. Second, security vulnerability. Third, limited error handling. Fourth, basic documentation. Now, let's go to the enhancement plan. 1. Complete the CRUD implementation by adding update and delete method. Currently, we only have create and read method. For a complete CRUD module, we need update and delete. And here's what the update method will look like. Notice the improvement over the existing code, comprehensive input validation, the specific exception types instead of generic one, proper logging, complete documentations, safe default behavior, meaningful return value. Enhancement plan 2, security improvement, remove hard-coded credentials. So here, I'll move credentials to a configuration system. Here's the approach that I'm talking about. This approach has several advantages, being first, no credential source code. Second, configurable for different environments. Third, fallback defaults. Fourth, flexible configuration. This follows industry security best practices and the 12-factor app methodology. Third enhancement plan will be error handling and documentation. These enhancements demonstrate specific skills that align with course outcome. Being here, complete software development will align with outcome 4, security coding practices with outcome 5. Then we have professional documentation with outcome 2, robust error handling outcome 4, design trade-offs outcome 3. So specifically, these enhancements that I have here primarily aligns with outcomes 4 and 5, supporting alignment to outcomes 2 and 3 here. Okay, next we'll go to category 2, algorithms and data structure. So for algorithms and data structure, let's see. For algorithms and data structures, the existing code is quite basic. The read method just wraps MongoDB's find function. So as you can remember, on line 45 here, we'll find find, and line 46 converts results to list. There's no actual algorithm implementation here, no sorting, searching, or data transformation happening in Python. All algorithmic work is done by MongoDB. So for the code analysis, analyzing against our checklist here, there are significant gaps. No advanced algorithms are implemented. No advanced algorithm. Um, no data structure beyond basic lists and dictionaries. No performance optimization like caching. The code doesn't demonstrate algorithmic thinking or understanding of time or space complexity. So here you go. It's the analysis. So for the enhancement, plan 1, error handling and implement a caching system using hash maps, Python dictionaries with LRU, which is uh, evic LRU eviction. So here, this this is the plan number 1. This implements several algorithmic concepts, being LRU cache algorithm using ordered dictionary to track access order. Second, hash map operations. Third, TTL expiration. And fourth, deterministic cache keys. Next, enhancement plan 2. Implement in-memory merge sort for client-side sorting. So I chose merge sort because it is consistent O and log n performance, and like quick sort's worst case, stable sort, so preserves order of equal elements, important for multi-key sorting. Third, good for link structures. Though we're using lists, it demonstrates the algorithm. And then lastly, classic divide and conquer. So it demonstrates fundamental algorithmic paradigm. Enhancement plan 3, data analysis algorithm for adoption trends using dictionary aggregation. So this is my plan for this one. This algorithm demonstrates 1, dictionary aggregation pattern which is common in data analysis. 2, nested data structures on dictionaries within dictionaries. 3, data filtering and validation, checking conditions before processing. 4, result transformation, converting aggregated data to report format. 4th, fifth, I mean, sorting algorithms using Python's theme sort for final ordering. So these algorithm enhancements demonstrate skills that align with course outcomes. So algorithm design and implementation aligns with outcome 3, data structure selection. So it aligns with outcome 3 as well as complexity analysis. And problem decomposition. All of those 4 align with outcome 3. Performance optimization aligns with outcome 4. So category 3, databases. So for databases, we have basic MongoDB connectivity, but it lacks advanced features. So as you can see here in line 18 to 23, line 18 to 29 establish a simple connection. So lines 36 to 45 here show basic insert and find operations. We're not using indexes, aggregation pipelines, schema validation, or any optimization features. My analysis reveals critical missing features. So here, what's missing? Indexing. No indexes created for frequently queried fields. No aggregation, not using MongoDB's powerful aggregation framework. Transactions, not using multi-document ACID transactions. Schema validation, not enforcing document structure. Performance optimization, not analyzing or optimizing queries. Advanced queries, not using geospatial queries, text search, etc. Database administration, not handling backups, replication, sharding considerations. So my enhancement plan will be I'll implement 3 key database enhancements. First, comprehensive indexing on fields like animal type and date of birth. Second, aggregation pipeline methods for complex queries that process data in the database. And third, schema validation and robust connection management with pooling and timeouts. These demonstrate database optimization and security mindset aligning with outcomes 4 and 5. In summary, my enhancement plans transform a simple database module into a complete professional system. For software design, I'll complete CRUD and improve security. For algorithms, I'll add caching and sorting algorithms. For databases, I'll implement indexing and aggregation. These integrated enhancements will create a product-ready animal shelter management system and that demonstrates my full stack development skills across all course outcomes. My next step is implementing the software design enhancements in milestone 2. So the final architecture that I will have the front end. So for the front end, I'll have the Flask web interface with HTML templates. Next, I have for the business logic enhance animal shelter class with all our improvements. For the database part, MongoDB with indexes, aggregation, and schema validation. For the infrastructure, configuration management, logging, error handling. So thank you for reviewing my code analysis and enhancement plans. I believe this comprehensive approach addresses all course requirements while creating a meaningful portfolio-ready project that demonstrates my growth throughout the computer science program. I welcome any feedback for my analysis and plans as I move forward with the implementation. So thank you so much for listening and I hope you guys have enjoyed the rest of the day. Thank you and bye.